Hello, welcome to Old School Science Demonstrations. I'm your host, Stephen Rakusik. Today's demonstration is tablecloth versus inertia. As always, there will be a little demo card right next to the video online, okay? And this would be a listing of everything needed for this demonstration. Also, there's a place here on the bottom for any kind of notes you would have to take. And I would suggest leaving this right with the materials up on your shelf. That way, whenever you need to grab this demonstration, grab the card, grab your materials, and you're ready to go, okay? A couple things we have to visit about before we begin is inertia and the first law of motion, okay? Now, inertia is the resistance of an object to change motion, okay? Now, there's a slight difference between that and the first law of motion, which in this case, we also include an outside force acting on it. So the first law of motion would state an object has a tendency of staying at rest, or an object moving at a constant velocity will stay at that constant velocity unless an outside force acts on it. And now what that means is, let's say if you're driving a car, okay? Now if you're driving a car, let's say going 55 miles per hour, heading north, and you let go of the gas, if it was a perfect situation and there was no friction between your car and the wheels, there was no pulling down because of the engine slowing your vehicle down, you would continue to move at that constant velocity. Now the outside forces would be your brakes, it'd be the engine pulling you down, and you eventually would stop. Kind of like if I push this can here, and I push it across, if it was a frictionless surface, no air resistance, no friction on the table here, I would give it a push, it would keep moving forever. But you notice it does stop because there's outside forces acting on it. Now we can also consider this if an object's sitting like this. So if an object's sitting like this, it's considered moving at a constant velocity of 0, and it's going to want to stay here. Now the more massive it is, the more weight it has, it's going to be harder to move. Kind of like comparing a football player to a first grader. It'd be a lot easier to push that first grader, not that you would want to, in comparison to the football player, okay? Now demonstration we're going to show today, a couple different ones, is actually going to help show this. First I'm going to start out by doing the simple demonstration over here. What I have is just some old covers from discs, CDs. And I have a piece of paper, okay, 11 by 17, with a hole in it. And I also have just a book for some extra weight. I also have a pencil I'm going to use to mark place on my table. So I'm going to bring this close to the edge of the table. About an inch from the edge of the table, I'm going to mark my hole, okay, with the pencil. I'm going to place that disc cover right up next to the hole and to the line I marked, about a quarter inch from there. I'm going to grab a piece of paper like this, and I'm going to do a karate chop and pull the paper through with one quick motion, okay? Give it a pull here. Now you notice the disc cover did move, and it moved almost past the edge of the table, and it moved probably an inch and a half or so. Now we can simply do this again by increasing the amount of weight on there with a massive object like a book, and we can start to show the kids in our class, or maybe your kids at home, that it is harder to move more massive objects. So I'm going to give this a little hit here, do the same thing. You notice that time I don't think it moved at all. We'll do a quick check here. I'll pull my book back without disturbing the case, and let's see, pull this back, and very little, if any at all. Looking more, maybe the tip of the pencil is all it moved, okay? So this is a quick little lead-up demonstration you can do to show the kids that mass does make a difference. The more massive something is, the harder it is going to be to move. I'm going to set this off to the side. Now I'm going to grab my materials now and bring them over here. And what I have is I have a sheet, which I'm using as my tablecloth, and what you need to do is take and cut off the edge. So I removed one edge of the sheet to make it a tablecloth. And you notice I kept it on the other three edges just to keep it together. I'm going to place this on my table, and I'll spread it out. And now I'm going to place my items on there. Now I choose to use the fake food just because that way I can keep it in my classroom and it's always there, it never spoils. But this definitely can be more fun if you're doing this at home or even at school to include real food. Just makes it a little more fun for the kids. Now I have a plate with some fake food, and I also have some clay to make it more massive. And I have a bowl, again with clay also in here. And lastly, I have a glass of water. Now I don't use any type of silverware. I did this once before in a freshman physical science class, and the student got caught right here with the fork. So never again. And I always make sure they wear safety goggles too, just to make sure nothing happens to their eyes. Now, I'm going to try this first of all, just to show you, and then I'm going to explain a couple of things about it that'll make it more exciting if you're doing this more as a class activity, or even activity at home at night with your kids. I'm going to go ahead and grab a hold of this. I'm going to pull down very quickly, and I usually count to 3. For one is it gives me a point to pull and kind of gets me excited to do it. Also, if there's kids in the crowd, they also would like to count along as you're doing this. So I'm going to count to 3, and the count to 3 I'm going to pull down, and I grab a hold of a good fistful here, making sure I don't disturb the tablecloth at all. If I do this now, and I have a little rolled edge here, it will knock this over. So I make sure to keep it nice and straight, and I grab a hold of a nice fistful, which I always say fistful to the kids. I'm going to pull it straight down towards my feet as fast as I can on the count of 3. Okay, 1, 2, 3. You notice a little bit of movement here, which I can improve on that, I guarantee it. Now, I'm going to show you a couple of techniques you can do to make this even more fun. Place my tablecloth back on there. And again, we showed in that first demonstration that it does make a difference if you change the amount of mass. Now, I could even include more clay in here to make it more massive. So something you can do is take and remove some of the weight from the items and make it a little bit harder. You can also shift the tablecloth this way. So say if you have a group of, let's say, 10 students, and they all try the first time and pull it successfully, then you can take and remove a little bit of that water. Okay. You can also remove some of the clay from each one of these. We'll set it off to the side here, and we'll have them try it again. And it becomes harder and harder as you do that, and especially as you move the tablecloth this way, again, shifting the items closer to this edge, because now they have to move a greater distance to be successful. Now, to make this easier for, let's say, smaller children, you actually can take and bring these right up to the edge here. So let's say, and I've done this before with 3- and 4-year-olds at different science camps and fairs. I've taken and I've moved the items almost so it's off the edge of the tablecloth, and they're all excited, and they get up there and do it. And you have to pull very little to get it to work, okay? And the kids get very excited about that. Now, I suggest trying this. It's a nice demonstration to show both the first law of motion and inertia. I do have a little more write-up in the lesson plan located right next to this video. And also check out that demonstration card too. It'll definitely help as you're planning for your classes. Thank you. I hope you enjoy this demonstration. Have a great day.